Okay, I'd like to finish up section 7.2 now. We're looking at applications of the normal distribution, and I had started problem 17. Just to recap that here, it says the magnitude of earthquakes since 1900 that measure 0.1 or higher on the Richter scale in California is approximately normally distributed with a mean of 6.2 and a standard deviation of 0.5. We're going to let the random variable x represent the magnitude of an earthquake since 1900 in California. Okay, we had already done parts A through F on that first page. I'm on part G now. It says determine the 40th percentile rank of the magnitude of earthquakes in California. Okay, a kth percentile rank means that k% of the data is going to be less than or equal to k. In this problem here, I want to know 40% of earthquakes are less than or equal to what magnitude? Okay. Now, because we're finding a magnitude, this is not a probability question, right? X represents the magnitude of an earthquake, and so I'm looking for an X value such that 40% of the data is going to be less than or equal to X. Well, let's see here. So X equals mu plus sigma times Z would be the formula for a Z-score, but when it has been solved for X. Now, you want to be using this formula whenever you're going to determine a kth percentile rank, as is the case here. We know mu and sigma, right? Those numbers were given to us. And so all we have to do is find our Z-score, and then we can plug in all three of these numbers and get our X value. Let's do that now. Okay, now because I'm looking for a Z-score and I'm being told to work with a 40th percentile rank, 40% of the earthquakes are going to be less than or equal to what magnitude? Less than or equal to are key words here to describe area to the left. So I'm going to be using the chart in reverse, and I need to be looking for 0.4000. That number is not listed in the group. Looks like 0.4013 would be the closest number to that. Okay, so we'll use that number instead. And the Z-score that correlates to that looks like negative 0.25. So I've indicated the number that I'm using there on the table. Z is negative 0.25. I'm going to plug in my numbers now. X equal mu plus sigma times Z. Mu is 6.2. Sigma is 0.5. The Z-score, we just looked that number up. It's negative 0.25. When you simplify, looks like I'm getting 6.075 as the answer. That'd be the 40th percentile rank. The interpretation of that then would be to say that 40% of earthquakes have a magnitude that is less than or equal to 6.075 on the Richter scale. Part H says determine the magnitude of earthquakes that make up the middle 85% spread of the magnitudes. So I've got a picture here. I want to answer the question, 85% of earthquakes are between which magnitudes? Okay, I'm going to call these two magnitudes x1 and x2. Now I've got a picture. X is normally distributed. So of course that means I'm looking at a histogram where the shape of the graph is bell-shaped and symmetric. The mean is at the center. The mean is 6.2. And I've marked out x1 and x2. Now make sure that those are the same distance away from each other since we're describing a middle 85% spread. And that area, therefore, would be 0.8500, representing the middle 85% of the information. Now the area under the entire curve is 1, right? The normal curve is a probability density curve. That's just fancy words for saying that the total area under the curve is 1. So if I've already represented 85% of the information, then the other 15% would be on the two tail ends of the bell curve. Or you're going to have 7.5% on either side there. The area to the left of x1, therefore, would be 0.075. The area to the right of x2 would also be 0.075. So now I've got a total area of 1 underneath the bell curve. Now, I'm going to be using the same formula, x equal mu times sigma times z, mu plus sigma times z. because I'm looking for two x values here, and it's all about area to the left. So to get x1, the area to the left of x1 is 0.075. I already know mu and sigma, right? Those numbers were given to me. I just got to get my z-score, and then I can plug in the information to get x1. The area that's given here is 0.0750, so I'm going to be using the chart in reverse. And let's see, 0.0750 is not listed. Okay, but I see here's 0.0749, that's the closest number. So I'm going to use that instead. Negative 1.44 would be the area, or would be the z-score, excuse me, that correlates to that area. So my first z-score, I'm going to call it z1, is negative 1.44. Mu is 6.2, sigma is 0.5. The z-score, I've already looked that up. And when I go to the calculator now and enter this in, I'm getting 5.48. Okay, so that'd be the value of x1. Now I want to find the value of x2. Well, again, it's all about area to the left. So the total area to the left of x2 would be where I take 0.8500 plus 0.075, or that would give me 0.9250. Well, if I've got 7.5% of the information is bigger than x2, then the other 92.5% of the information is going to be less than x2, right? And again, I want to be calculating the z-score here and using this formula x equal mu plus sigma times z. So let's go to the chart and look up that area. Do we see 0.9250 listed? No, we don't. Okay, and the closest number to that is 0.9251. The z-score that correlates to that is 1.44, and so that's what I've got indicated there for z2. Notice how z1 and z2 are opposites of each other. I think that should make total sense to us, because x1 and x2 are the exact same distance away from the mean. Z1 and Z2 are going to be the exact same distance away from their mean on the standard normal curve, which has a mean of 0. So I guess with that said, knowing that Z1 is negative 1.44 means that I can automatically know that Z2 is going to be the opposite of that number. I can save some time and just go right to that Z value. When you plug the numbers into the formula here, you should get 6.92. And so it looks like 85% of the magnitudes are going to be between 5.48 and 6.92 on the Richter scale. Most of the time when an earthquake happens in California, it's going to be between these two magnitudes. Then 85% of the information is between these two magnitudes. All right, problem 18 is another problem that I wanted us to look at. It's the last one here on the sheet. It says the reading speed of 6th grade students is approximately normal with a mean speed of 125 words per minute and a standard deviation of 24 words per minute. Let the random variable x represent the reading speed of a 6th grade student. Part A, what is the probability that a randomly selected 6th grade student reads more than 140 words per minute? Okay, x is the reading speed, so I want to find the probability that that speed is more than 140 words per minute. That means that x is greater than 140. Change the variable from x to z using the formula for a z-score. So I want x minus mu over sigma, and then do the same thing on the other side, only use the actual numbers. X is 140, the mean is 125. You're dividing by the standard deviation, which is 24. 140 minus 125 over 24 is 0.63 if you go nearest two digits. We're describing area to the right of 0.63. Table only gives area to the left. And so what's coming next would be using the complement rule. Okay, take 1 minus the probability that z less than or equal to 0.63. Equal signs don't matter, but still make sure that you flip the sign there because you're describing area to the left now. The area to the left of 0.63 is 0.7357, and that's what I've got here. Subtract that number from 1 and you get 0.2643. So the interpretation would be to say that if we were to consider all the 6th grade students and randomly select one of them, we would have a 26.43% chance that that student would be reading at a speed of more than 140 words per minute. Part B, what is the probability that a randomly selected 6th grade student reads between 110 and 130 words per minute? Okay, so I've got that set up. X is the reading speed. I'm wanting to find the probability being between those two numbers. Change the variable using the formula for a z-score. The left z-score that I'm getting is negative 0.63. The right z-score is 0.21. I want to find the area between these two z-scores. So I've got to take the area to the left of the larger z-score minus the area to the left of the smaller z-score. Some students will accidentally have these numbers flipped. Don't do that, because then you'll have a negative, and of course probability can never be negative. Now we're ready to go to the chart. The area that is to the left of 0.21 is 0.5832. So that's my first number. And then the area to the left of negative 0.63, I'm getting, let's see here, that's going to be 0.2643. All right, subtract those numbers and you get 0.3189. The interpretation of that would be to say that if you were to consider all the 6th grade students and randomly select one of them, you'd have a 31.89% chance that that student would be reading at a speed that is between 110 words per minute and 130 words per minute. Part C, what is the reading speed of a 6th grade student whose reading speed is at the 90th percentile rank? Okay, well, the 90th percentile rank in this problem would mean that 90% of 6th grader reading speeds are going to be less than or equal to how many words per minute? X represents the words per minute, right? So this is not a probability question. We need to find an X value such that 90% of the data is going to be less than or equal to X. Well, I need to use the formula X equal mu plus sigma times Z in this. Mu is 125 words per minute. Sigma is 24 words per minute. So I just got to get my z-score here. I'm working with a 90th percentile rank, so the area to the left of this z-score would be 0.9000. I need to use the chart backwards, and let's see, 0.9000 is not listed. Looks like the closest one to that would be this guy here, 0.8997. So the z-score that would correlate to that number would be 1.28, and that's what I've got marked there. Plug in the numbers and simplify. You get 155.72. I've rounded that to a whole number value. So I would conclude that 90% of 6th grader reading speeds are going to be less than or equal to 156 words per minute. Okay, part D is the last one. A school psychologist wants to determine the reading rates for unusual readers, that is both slow readers and fast readers. Determine the reading rates that would make up the middle 90% spread of all the 6th graders. Now this is a middle 90%, not a 90th percentile rank. Two different questions here. I'm going to let x1 and x2 represent these two speeds that I'm supposed to find. And those are going to serve as cutoff points for unusual readers. X is normally distributed, so I've got my bell curve drawn. The mean is 125, and that's right in the center. And I'm representing 90% of the information in the middle here of x1 and x2. Of course, the entire area under the curve is 1, so if I've already represented 90% underneath, then the other 10% is going to go at the tail ends, or you're going to have 5% on the left tail and then the other 5% on the right tail. To get x1, I'm using this formula here, but I got to get my z-score because I know mu and sigma. The area to the left of x1 is 0.05. And so 0.05 is not listed. Let's see here. We have 0.05. I don't see that. But looks like there's two numbers that are the same distance away from 0.05. Now we've seen a situation like this before. I don't want to use one z-score over the other, right? Since these are the exact same distance away, I'm going to take an average of z-scores. Okay, I'm going to go right in the middle, and I'm going to call it negative 1.645. This is a rare time where we get a 3-digit decimal for a z-score. Okay, this usually doesn't come up. It's usually always 2-digit z-scores since you're always just picking off the closest value, but I'm not doing that here. So here's my z-score. Okay, plug in the numbers into this formula and simplify, and we get roughly 86 if you round to the nearest whole number value. Okay, and so that's going to be my left cutoff point. My right cutoff point is where I got to find x2. The area to the left of x2 would be 0.9 plus 0.05, that's 0.95. Okay, or 95% of the information is going to be less than x2. Again, I'll have to get my second z-score. And 0.95 is not listed. And again, we see the same situation here happen where we don't have a definitive closest number, right? 0.9495 and 0.9505 are the exact same distance away from 0.95, so I don't want to use one z-score over the other. Instead of using 1.64 or 1.65, I'm going to go right in the middle, and I'm going to call it 1.645. Notice how these two z-scores are opposites of each other. Again, that's by the symmetry of the bell curve. I could have recognized that early on here and save some time with this. Plug in the numbers, and you get roughly 164 then as the right cutoff point. So the cutoff points for the middle 90% spread of all 6th grader reading speeds are going to be 86 words per minute and 164 words per minute. All right, anyone who's at a speed that is outside of those numbers would be an unusual reader. That means that they're reading unusually slow or they're reading unusually fast for their particular age there. Okay, we are now done with Chapter 7. There's only 2 sections that we had looked at. So the homework is, the rest of the homework in 7.2 is on page 348. You can be sure to look at the rest of these application problems.